Have you ever wondered how some of the most popular games like World of Warcraft and Angry Birds handle their complex logic so smoothly? Well, the secret ingredient? Lua! Today we are kicking off our journey with Lua, one of the fastest and most lightweight scripting languages in the world. And the best part? It is easy to learn and can be used for games, web apps, automation, and even AI. And by the end of this episode, you'll have set up Lua, a coding environment on your PC, and return your first Lua program. So first of all, what is Lua and why should you even care about it? Lua, meaning moon in Portuguese, is a lightweight scripting language that was created in 1993 in Brazil and has since become a go-to language for developers who need speed, flexibility, and simplicity. Think of it as a Swiss Army knife of coding: small, powerful, and insanely useful. So why should you learn Lua? It is super simple, meaning that it has no complex syntax, no unnecessary rules, just straight up coding. It is blazing fast and it works everywhere: PCs, mobiles, and even tiny embedded devices. And it also plays well with others. Lua easily integrates with bigger programming languages, making it a secret weapon for developers. Well, now that we know how awesome Lua is, let's get started with coding. And before we start coding, let's get everything ready. In order to install Lua on Windows, we have a simple measure that you can take. Here we have a GitHub link which provides us an executable file for downloading Lua on our system. And we'll provide this link to you guys in the description. Meanwhile, let's install this file on our PC. It should start installing after you click on this, and we'll wait for the installation to be done. Here our file has finished downloading. Let's open up this folder and let's execute this file right now. So I accept the agreement, then next. Choose our destination. I'll keep it as default, and next, next, and then next. I don't want to create a desktop shortcut, so I'll just click on next and install. So once the installation finishes, to check if the installation has worked or not, you can click on finish, then open up your command prompt by typing cmd on start, and then just type out Lua and hit enter. Now if the installation was successful, it should show you the version of Lua that you have installed. Otherwise it will tell you that Lua is not an executable batch file. So in our case, we have Lua successfully installed, and now that we have Lua installed, we can open up VS Code, add on some extensions, and then we are all set for running our first Lua program. So I have already created a folder to test out some code. I have some extensions that I want you guys to add on to your VS Code so that it is easier. So the first extension that we have here is Lua, which is by Sumniku, and we have already added this onto our VS Code. And another extension that will prove helpful to us is the code runner, which helps us to run code of different languages, which includes Lua, pretty easily. So after installing these extensions, we can head over to our file to write our first ever Lua program. In this case, we are starting with our print function, which outputs our given message onto the standard output, which is typically the console. Now, it depends on the use of the print function, but it can be used to print out our message onto our console or even our screen. So it depends on where the print function is being used. In this case, we will output this code onto our output section. So after typing out print and opening a set of parentheses and then writing our message or our string inside the parentheses, we are all set for outputting our code. Now, if you have Lua installed on your computer and you have added the extensions that I've mentioned, you should be able to click this button right here and see the output to your code. So after clicking this button, we can see that it outputs to hello world. And there you have it. You have written your first ever Lua program. Now let's have a look at a real life example. Imagine you are building a simple app that sends messages to its users. The first message the app sends could be hello user, or hello the name of the user, welcome to Lua. And using the same print function, you can display messages in your app. Let's say you wanted to greet someone personally. You could store the user's name in a variable like this. we could create a variable with the use of the local keyword, that is local username equals, let's say, John. Now, if we want to use this username variable inside our print function, we have to use concatenation. And concatenation in Lua is achieved by the dot dot operator, and I'll show you this right now. So suppose we have to write hello, the user's name, so dot dot concatenation, and then the variable name, so username, and then dot dot once again, welcome to Lua. And then we can save this code right here and then execute it. So hello John, welcome to Lua. Now this doesn't have any spaces because I have not provided spaces here. If we add spaces and execute it and save it and execute it, we'll be greeted with hello John, welcome to Lua. So here we use the dot dot, that is the concatenation operator, in order to concatenate or join together the string hello with a username variable and welcome to Lua, which creates a personalized greeting. So this is how you use variables to concatenate strings in Lua. And now it's your turn. You can open up your text editor or VS Code and try modifying the code. You can change hello world to any other message that you like. For example, you can use variables or string variables to type out your introduction, hello, and you could type out hello, my name is, and then space, and then our concatenation operator, and then our variable name, so username. Save the code and then execute it. So hello, my name is John. So each of you guys can try out your own code or your own use of the username variable or any other variable that you define in your own way. And you can see how the print function works and the different creative methods that you can utilize variables. Since we'll be discussing about variables more in the next episode, let me tell you some useful stuff related to the print function. So let me remove this variable right here and just demonstrate how we can use our print function. If you want to print something in the new line, you can use an escape character, which is the backslash. So backslash n, and everything after this is printed on to the new line. So hello, my name is Lua, let's suppose. Now if we save this and execute this code, hello, my name is should be printed out in the first line, and then this character should act as an escape character and print whatever there is after the escape character onto a new line. So let's save our code right here and then execute it. So hello, my name is Lua. If we were to remove this space after our new line character, that is backslash n, save it and then to execute it, it would create hello, my name is Lua without any space. So this is how you print out stuff onto the new line. You use the escape character, which is backslash and then n. And this is not the only use of the escape character. I'll give you an example. Suppose I wanted to print out John said I know all of Lua, and the I know all of Lua should be in quotes. Now if we have noticed, our strings start and end with double quotes or single quotes. So what if you wanted to use the quotations inside the string itself? Let me try it out real quick to show you what it results in. So John said quotations I know all of Lua. We can clearly see that I know all of Lua is being typed outside of the string. So in order to use these quotation marks inside of the string, we can make the use of the escape character, which is backslash. Now the use of the backslash will make it so that this quotation mark is typed out inside the string itself. So if I want to type out another quotation mark, I will use the backslash and then quotes again. Now if we save this and print it out, we'll be able to observe that John said quotations are being typed out as well. So that was a small demonstration of the use of the escape character, that is our backslash. It can be used to print stuff onto the new line, or it can be used to type out quotes inside a string. And that was it for today's video. A quick recap for you guys. We discussed how Lua is a lightweight, fast and flexible scripting language used in many industries including gaming. we wrote our first Lua program to print hello world on the screen using the print function, and we explored about how we can use the concatenation operator to concatenate variables onto our string. And also at the end we just explored how we can use the escape character in different ways. What's next? Now that you have written your first Lua code, you are ready for more. In the next episode, we'll dive into variables and data types and how to use them in our programs. But before you go, make sure you drop a like if you found the video helpful and subscribe to our YouTube channel. And if you want a certificate for completing this course, you can earn a certificate and show off your Lua skills by signing up at codin.com. So it's codin.com. And there are multiple courses including Lua for which you can get a certificate. So make sure you check out codin.com, and we'll see you guys in the next video. Bye bye. You could store the number of likes in a variable. So I'll change this name to local likes, and let's say you have 100 posts on your like. Let's be generous. And if you want to print out this variable, we can use the concept of string concatenation. So your post has, we'll use the concatenation operator, that is dot dot, and then likes, and then dot dot again, since we want to join another string that says likes, likes, an exclamation mark. So let's run this and see what it outputs to. Your post has 100 likes. Now if we keep this space right here, it should output to space 100 likes. Now imagine this post gets more and more likes. You could easily update that variable in this manner. So likes equals to likes. Let's say your post has gained 50 more likes. So likes plus 50. Now if we copy this same line of code below this variable updation, or updating the variable, we'll be able to see that the like count will be upgraded to 150 likes. So you just updated the value of likes from 100 to 150. Now, since we have a decent idea about what variables are, let's discuss about data types in Lua. Variables can store different types of data, and each type has its own values. In Lua, the common data types include numbers at first. So numbers are the data types that stores, well, numbers, integers or floating points. And another data type is string, which stores a sequence of characters, that is a string. In this context, hello world is a string. The Boolean data type stores true or false values, and the table, that is tables in Lua, stores collections of data like arrays or dictionaries. And the function data type stores functions. And the nil data type, this data type is a bit special. It represents the absence of a value, like nothing or empty. So let's look at each one in detail. First of all, our number data type, which we just discussed in an example right here. And I'll showcase the number data type with another example. So let's say local, our age is 25. And this right here, and this is how you comment in Lua, by the way, 2 dashes, and then you can write your comment. So this is an integer, and local height equals 5.9, let's say, and this is a float or a decimal. So the number data type consists of both integers and floats. And let's see how they are displayed by printing each one out. So print age, and let's join age, and then print height, and then height. So let's run this. It outputs to age 25 and height 5.9. And fun fact, Lua actually doesn't differentiate between integers and floats. It just treats all the numbers as floating point, so there's no need to worry about choosing the right type. And moving on to string, let's create a string called greeting. So greeting equals to hello, let's say name, and we'll create our name variable right here. So local name equals, let's say, Sam. So we even did this in our previous video. I'm just going to showcase how this works. Print and then greeting. So if I'm correct, this should output to hello Sam. So hello Sam. Now of course there's no space. I always forget a space. Hello Sam. And this is how strings and string concatenation works. Moving on to booleans, it's just true or false values. A boolean can only hold one of two values, which is true or false. And this is useful when you want to make decisions in your code. We'll explore this more in the next episode, which is related to control structures. Now here is an example, or a teaser of the next episode, let's say. So let's say we create a local variable called is raining. Now this can be either true or false. Let's set this value to false. And we'll say if is raining, then print better bring an umbrella. Else it should print it's a sunny day. So, and after a conditional statement, we should print out end and then run this code. So since our is raining value is set to false, this outputs to it's a sunny day. If this condition is true, that is if raining is true, then it should output to better bring an umbrella. So this is a teaser of how conditional statements work. You have the if keyword, our condition to be true or false, our then keyword, and after that our condition or our code to be executed if the condition is true. Now I gave you this teaser to demonstrate how booleans work. It can either output to true or false. Moving on to tables, that are the ultimate data collection tool. A table in Lua is a collection of values. Tables are super important because they can act like arrays, dictionaries, or objects. Pretty much everything you need in one. And here's an example of a table, like an array. So I'll remove this. Local fruits equals a set of curly brackets and then apple, banana, and then cherry. Now, like arrays in pretty much many programming languages, we can access these values through indexing. So fruits and then 1 outputs 2. I want you guys to guess what it would output to. Now we have been taught on and on in many programming languages that arrays always start with the indexing of 0. But in Lua, that is not the case. In Lua, arrays start with the indexing of 1. So this should output to apple and not banana. So it outputs to apple. And this is just an example of how tables can be used as arrays. You can even use tables as key and value pairs like a dictionary. So if I were to change this name to person and then have a key called name, so name, and then I would have to use equals to and then Alice. Remove all of this and then age equals 30 and job equals developer. Now, if you are familiar with dictionaries in Python and JavaScript, you might have noticed that we did not use the colon symbol, and instead we use equals to symbol to assign values to our keys. In this case, all of the variables in our left are the keys, and the values on the right are our values. So if we want to access a specific value, we have to write the name of the dictionary and then the key. So print person.name should output to Alice. So it outputs to Alice. It might be clear from this example that tables are incredibly flexible and super useful, which is why they are used for so many things in Lua. Now let's move on to another data type, that is functions. You can store functions as variables too, and here's an example. If you type out local greet equals to the keyword function and then our parameter, that is name, and write it as return hello dot dot name and then end. This end symbolizes the end of the function, and this return returns the value. And you might be familiar with the term of parameters, which is the values that we pass into a function that is defined here. And when we actually call the function and pass in values, it is called an argument. So greet, and if I wanted to pass my name as an argument, I would type out Sam. So greet Sam. This should output to hello Sam. So hello Sam. And this is just the beginning and just a simple example. We'll dive deeper into functions in later episodes, but for now, understand that functions can be treated just like any other data type in Lua. And our last data type for this video is the nil data type. Sometimes you may want to remove a value from a variable or just indicate that something doesn't exist. You can do this using nil. If I were to type out a variable, let's say a number, age is 25, and if I wanted to remove this value of 25, I would type out age equals nil. And if I print out age, it will output to nil. So there's that. So that was it for the data types that we are going to be discussing today. But before episode 3, we have a task or a challenge for you guys. You are to create a shopping list program which might use a table to store items and their values. And you are to calculate the total price of all the items on your shopping list. So this is a pretty mildly challenging task, but you'll have fun doing it. So we hope that you guys complete this task, and if there is any confusion, you can always leave a comment. So in this episode, we explored variables, different data types, and how to use them in Lua. And in the next episode, we're going to be diving into the topic of operators and expressions, so make sure you tune in for that. If you liked the video, make sure you drop a like and subscribe to our channel for more videos like this. And we'll see you guys in the next one. Have you ever wondered how your favorite game calculates your score, checks if you've beaten a boss, or combines your name into a custom message? Well, that's the power of operators and expressions in Lua, and today you're gonna master them. Welcome back, everybody, and in this episode we're diving deep into the secret sauce behind math, logic, and string magic in your code. So whether you're building games or just love clean logic, this one's packed with real-life examples and powerful tools. And hey, if you want to flex your Lua skills with a certificate, you can head over to codin.com to do a course and claim your certificate. The link's down below in the description. So buckle up, it's time to level up your code with Lua operators. So first of all, what even are operators? An operator is a symbol that tells a computer to perform a specific operation. For example, when you add two numbers, the plus symbol is an operator in Lua. And there are different types of operators in Lua. They are arithmetic operators, which are for math, relational operators for comparisons, logical operators for making decisions, assignment operators for storing values, and concatenation operators for string manipulation and string magic. And we're going to be breaking down each and every one of them. So let's start with arithmetic operators. Arithmetic operators allow you to perform basic mathematical operations on numbers. So we're going to create two variables that store two numbers. So first is num1, which stores 10, and the next is num2, which stores 5. Now I'll use a bunch of operators to print out the results of operations. So print num1 plus, this is the addition operator, so plus operator, plus num2, and likewise print num1 minus num2, print num1 divided by num2, then print num1 multiplied. The star symbol or asterisk symbol is the multiplication operator, num2, and then print num1 modulo num2. Now I'll explain about this in a while, and print num1 to the power of num2. So you might have guessed already from the operators, these are pretty common in mathematics themselves. This adds the two numbers, this subtracts the two numbers, this divides num1 by num2, this multiplies num1 by num2. This actually divides num1 by num2, but instead of the division or the quotient, it provides you the remainder of the division. So we'll see what the remainder is. Now you guys can observe that num1 divided by num2, that is 10 divided by 5, leaves no remainder. So this line should output to a 0, and this is the power symbol in Lua. So let's see what all of these output to. So 10 plus 5 is 15, 10 minus 5 is 5, 10 divided by 5 is 2.0. This is a floating point value since it is a division, and 10 multiplied by 5 is 50, and since 10 divided by 5 leaves no remainders, this line here, that is num1 modulo num2, prints out a 0, and this num1 raised to the, or 10 raised to the power of 5, prints out 100,000. Now in order to further demonstrate how the modulo operator works, I'm going to change the value of num1 to 12, and you might guess what this will output to. 5 divided by 12, actually it only divides up to 10, so the remainder is 2, so this line should output to 2. So you can see right here. Now if I were to change this to 16, I want you to guess or to try it out yourselves what this would output to, and if you guess it right, let me know in the comments. Well, now we can move on to relational operators that are for comparing values. So the relational operators allow you to compare two values, and this is super important for making decisions in your program. And here are the main relational operators. This symbolizes equal to, this symbolizes not equal to, less than or equal to, greater than, and greater than or equal to. Now let's use these in a real life scenario, comparing the scores of two players. So I'll remove all of this code, and I'll create two variables per player score. So local player 1 score equals, let's say 150, and then another player score variable, so player 2 score equals 200. Now print player 1 score equals to, double equals to, which compares if they are equal or not, player 2 score. Now this will give out a result of true or false. If player 1 score is equal to player 2 score, this will output to true, or else it will output to false. So since player 1 score and player 2 score are not equal, it outputs to false. Let's use our other operators as well. Let's see and print if our player 1 score is less than player 2 score. Now since 150 is less than 200, this should output to true. So true. And if we print out the opposite, it should output to false. So player 1 score is more than player 2 score, should output to false. So false. And quick tip, these operators return a true or false value. So you can use these results in control structures like if statements to make decisions. Now, after the topic of relational operators, we can move on to logical operators. Logical operators allow you to combine conditions and make more complex decisions. Here are the key logical operators in Lua. The AND operator, for which both conditions must be true to return a true value. The OR operator, in which at least one condition must be true for it to return a true value. And the NOT operator, which reverses the Boolean value. So true becomes false and false becomes true. Now let's put them into action with a game scenario. So let's say our player level is 5. So local player level equals 5, and our health, so player health equals 50. Now if we want to check if the player is eligible for a bonus, we can set a certain condition. So if player level is more than 3 and player health is more than 30, then we can print out you are eligible for a bonus. Or you could print out bonus unlocked. Else you can print you need more health or level. And in order to end our if else condition, we need an end keyword. So end. Now there we have it. This is the use of our AND logical operator. Now since our player level is more than 3 and our player health is more than 30, it should print out you are eligible for a bonus and bonus unlocked. So let's run this and see if it's true. So you can see that this condition is executed since both the conditions are true. And now in order to show you guys the use of the OR operator, I'll create another if condition. So this time let's say that if player health is more than 0 or player level is more than or equals to 10, then print out you are still in the game. Else it will print out game over. So end. Now this OR condition makes it so that the player is still in the game if their health is over 0 or their level is more than or equal to 10. So in our condition, our player level is 5. So this condition is false, but our player health is more than 0, which is 50. So at least one of these conditions is true. So this if condition should execute. So let's see if that happens. So you are still in the game. So these examples pretty much give you an idea of how AND and OR work. So after learning about these logical operators, let us move on to assignment operators. So other programming languages might have assignment operators like this. If you want to increase the value of a variable by 10, you would write the name of the variable, then plus, then equals to, and 10. But this is not how it works in Lua. If you wanted to increase the player level by 10, you would have to manually type out player level equals player level plus 10. So if I print out player level right now, it should be increased by 10. So player level, and then I'll run it, and it should print out 15. Now similarly, you can do this with any other arithmetic operator. So if I wanted to multiply this by 10, I would type out asterisk. If I wanted to decrease the variable's value by 10, I would type out minus. If I wanted to divide the variable by 10, I would type out slash, and so on. So basically, an assignment operator in Lua is the value and then the operation that you want to perform on the value. This is like updating the variable by increasing or decreasing its value. So these are assignment operators. Now for the concatenation operator, you already know that since we have discussed that in our previous episodes as well. We use the dot dot operator. So if I wanted to type out say name equals Sam, and if I wanted to type out print hello, and then I would want to join the name variable. So this is how you concatenate strings. So hello Sam. And if there was an integer in the variable's place, suppose age is 25, and I would type out age, it should still give out hello 25. And fun fact, in Lua everything is dynamically typed, so you don't need to worry about specifying the data type. It will automatically convert and concatenate the values for you. And that is a wrap for our episode. In this episode, we explored operators in Lua, which are the building blocks for performing calculations, comparisons, and logic in your programs. If you found the video helpful, hit that like button and subscribe to our channel for more videos. In the next episode, we'll be diving into this topic of control structures like if statements and loops, so make sure you don't miss it. And until then, bye bye. Ever wondered how games decide when to attack, open doors, or trigger secret events? Well, it's not magic, it's logic. And that's where control structures come in. Welcome back, everybody. And in this episode 4 of our Lua series, we're unlocking the real power moves in Lua. Control structures. Control structures that give your game the brain that it needs. And control structures comprise of if statements, that is conditional statements, and loops. So these are the ultimate tools for making decisions and repeating actions in your code. Think of it like your morning routine. You decide whether to hit the snooze button or not, that is a conditional statement or an if statement, or how many times you check your phone before actually getting out of bed. So those are loops. And let's see how Lua makes these decisions with clean, simple logic that will level up your scripting game. So let's get started. So as always, before we start coding, first of all, let's discuss what are control structures. Well, control structures are the fundamental tools in programming that allow us to control the flow of the program. They let us decide what to do next based on conditions or repeat tasks over and over again. So here are the main types of control structures that we'll be exploring today. First of all, we have conditional statements. These statements are executed on the basis of conditions. The conditions that we define return a true or a false value. So we take decisions based on those true or false values, that is conditions. The next control structure that we will be discussing today are loops. These include for loops and while loops, and as the name suggests and the symbol suggests, these are for repeating actions multiples of times. And the final concept of control structures that we'll be discussing today are of break and continue. These help us to break out of the loop or skip our loop into another iteration. And we'll be discussing more about this later in the video, so you don't have to worry anything about that. Now, let's get started with conditional statements. In real life, we are constantly making decisions. For example, if it's raining, I'll take an umbrella. Or if I finish my homework, I will watch Netflix. Similarly, in programming, we can use if statements to make these kinds of decisions. The if statements checks if a condition is true, and if it is, the code inside the if block will run. And I'll show you guys a demonstration. So, if I create a variable called local temperature and set its value as 18, for example, and then I go if temperature is more than 20, then print it is warm outside. and after that we'll end our if block. This is used to end our if block. So according to this condition, if the temperature is greater than 20, then this code block that is inside the if block should execute. So in our case, since temperature is 18, which is not more than 20, this condition is not true. Hence this code block will not be executed and nothing happens. So nothing is our output. Now sometimes you just don't want to check one condition. So if our condition fails, we would want our program to take an alternative action. So in that case, our else block comes into use. So if you want to provide an alternative action if the condition is false, you can do that with else. So this is as it is, and we'll create we'll create an else block. So else print it is a bit chilly outside. So let's run and see our program. So since our first condition, that is our if condition, is not true, our else condition is executed. And this is basically how the if else condition works. And you might be wondering, what if we want to check for more than two conditions? And that's where the else if comes in. It allows you to check multiple possibilities. So first of all, let's create another if condition. If temperature is more than 25, then print it's really hot outside. And then instead of if, we'll create an else if condition. So else if temperature is greater than 20, then print it's warm outside. Else, and if neither of these conditions are true, else print it is a bit chilly outside. So if I update this value of temperature to 26, we will see that this condition, our first condition, that is the if condition, will execute. So it's really hot outside. Now if we update our temperature to 23, it is warm outside. So this else if condition is being executed. It checks for the if condition first and then the else if condition, and if these both conditions fail, then else condition. Now you can keep on adding else if conditions as per your requirement, and that is if we have multiple conditions that we want to check before writing our default, that is our else code. So it is a bit chilly outside. So if I root 10, it should execute to it is a bit chilly outside. So this is how the if, else if and else block works, and hope you guys understood it well. And after we have discussed about conditional statements, let's move on to loops. So loops are perfect for tasks that you need to repeat. For example, a game loop that runs until the player wins or loses. And repeating actions like checking inventory, updating the score, or printing messages multiples of times. So there are two main types of loops in Lua. They are for loops and while loops. First, let's start with a for loop. A for loop repeats a block of code a fixed number of times. For example, I'll delete this code, and if I write for I equals 1, 5 do, and then our code to loop print this is repetition number, and then our concatenation operator and our I, that is loop variable. This variable right here is called the loop variable since we are using this for a for loop. And after our code, we'll type out end and then execute this. We can see that this statement is looped 5 times, and each time the value of I, this is the loop variable, is increased by 1. So 1 during the first iteration, during the second iteration this value moves on to 2, 3, 4 and then 5, as you can see here. Now if I wanted to print out the values up to 10, I would just write 10 over here and it would print out to 10. But what if I wanted to iterate the value or increase the value of I during each iteration by the number 2? So if I wanted to print out 1, then 2 increases, then 3, then again 2 increases, then 5 and so on, I would have to put another parameter here, that is our step variable or our step number. So if I put here 2, 1 or the value of I will increase by 2 during each iteration. So if I run this, it should output to 1, then plus 2, 3, and then 3 plus 2, 5, 5 plus 2, 7, and 7 plus 2, 9. And since we have only set our range for I up to 10, 9 plus 2, 11 is not printed out at all. Now, if we want to print descending numbers, it is a bit different. So if I wanted to print out values from 10 to 1, just doing this much would not be enough, and it will not output to anything. If I wanted to decrease the value of 10 all the way to 1, I would have to put minus 2 if I want to decrease the value. So it should print out 10, 8, 6, 4, and then 2. Now, if I want to decrease the value by 1, I should put minus 1, and it will do so. So this is a for loop in Lua. So the for loop is like a countdown or count up. It repeats a task based on a number. Now, this is not the only way you can use a for loop. You can also use a for loop to go through tables, which are like arrays in Lua. And here's an example where we loop through a list of favorite fruits. So we'll define a variable called local fruits equals apple, then banana, and then cherry. So we can write it as for I equals 1, and then hashtag fruits do print I love, and then fruits with an indexing of I. And after we are done with our code, end. So hashtag fruits gives us the length of the table, or the number of elements present in this table called fruits. And the loop runs once for each fruit in the list, which is shown by the increasing value of 1 or I. So fruits with the ith index, it will access each value inside this table. So let's see what it prints out to. So I love apple, I love banana, and I love cherry. So there's no space for now, so I'll put a space here, so it'll output through this. And these are the use cases for a for loop. Now moving on to a while loop. A while loop repeats a block of code while a condition is true. For example, let's say we have a variable called counter. So local counter equals 1, and then while counter is less than 1 or less than 5, less than or equals to 5, do print this is repetition number once again, and then dot dot counter. Now we do need an exit condition, and I'll tell you what an exit condition is in a while. So we'll need to, in order to exit out of this while loop, we will need to increase our value of counter. So counter equals to counter plus 1, and then end. So if we did not put this exit condition right here, this loop would keep on executing, since the value of counter would always be 1, hence it would be always less than or equals to 5. So as long as this given condition is true inside a while loop, the code that is present inside the while loop's code block will keep executing. So we put this here in order to exit out of this while loop. Now during each iteration of the while loop, the value of counter will increase by 1, so it will eventually reach 5, so and greater than 5. So once it reaches 6, this condition will be false and will exit out of the while loop. So let's run this code and see our output. So 1, 2, 3, 4, and then 5. Now if we did not have this line right here, which increases our counter by 1 during each iteration, we would never exit out of this while loop. This would keep our value, the value of counter would be 1 during each iteration, and this condition would always be true because 1 is always less than 5, and this code block would keep on looping and looping. So this is our exit condition. Now there is another way of exiting out of a loop in Lua. So I will showcase the use of the break statement. So for I equals 1 to 10, do if I equals 5, then break. So this stops the loop when I equals to 5. And then we have to write our end statement for this if statement, and then our normal code. So print I and then end. So you might be able to take a guess what will happen if we execute this code. Once the value of I reaches 5, this break statement will execute. That is, this condition will be true, and then our break statement would execute, and we will exit out of this for loop. So it will print out values up to 4. So 1, 2, 3, 4, and then it breaks out of the loop. And that is how a break statement works. We can define a certain condition for the loop to break and use the break condition inside of the code block, and then it will break out of the loop when the condition is fulfilled. So that was it for today's video about control structures, and we have a challenge for you guys. Your challenge is to create a number guessing game where the player has to guess the right number within a limited number of tries. You can use for or while loops. And that is it for our video. If you found the video helpful, make sure you drop a like and subscribe to our channel for more such videos. And our next video will be about functions in Lua, so make sure you tune in for that. And until then, bye bye. Welcome back everybody. In episode 5, we are getting into one of the most useful tools in programming, functions. They let you group your code, reuse it, and keep things tidy. It's like saving yourself from doing the same task over and over. Think about it. Writing a greeting paragraph 100 times would be really exhausting, but with a function, you can write it once and just call it whenever you need. Simple and efficient. Today we're going to be discussing what functions are and how functions are used in Lua. And if you're working through this course and want a certificate at the end, check out coding.com, the link is in the description. Alright, let's make your code cleaner and more powerful. Let's get into it. So first of all, what are functions? A function is like a recipe. It takes some ingredients called parameters, mixes them together, that is, it does some work, and then it gives you a result, that is the return value. So this allows you to write a piece of code once and reuse it as many times as you want. Think of it like this. You don't have to bake the same cake every time you want to eat it. Once you've got a good bakery, that is a function, you can just place an order and get the same delicious result every single time. And all of that without having to do all of the work yourself. So let's see how you define a function in Lua. In Lua, you define a function with the function keyword, followed by the name of the function, and a pair of parentheses that hold any parameters, which are optional of course, and at the end of the function, you'll use the end keyword to close it off. So let's define a function with the function keyword called say hello. And after we define a function, we write the code to be executed below it, and let's say this function prints hello world. Simple as that. And after we are done with our function code, we end the function with the end keyword. So this function is pretty simple. It just prints out hello world every time it is called. And in order to call and use a function, you just have to type out its name followed by a set of parentheses. So this is calling the function. Now let's run and see what this function outputs to. So it outputs to hello world, since we are calling the function and the function prints out hello world. Pretty simple, right? Now that was the simplest way that you can use a function. And that of course means that there are other ways that you can use a function. So you can also use functions by using parameters. So think of them as ingredients in a recipe. These are values that you pass into a function to influence its behavior. And here's a function that takes a name as a parameter and prints a personalized greeting. So function greet, and we'll pass in name as a parameter. So print hello, and then our concatenation operator dot dot, and the parameter that we passed in, that is name. And let's say we have a exclamation mark as well, and we'll end this function, and then we get to call it with different arguments. So suppose Alice, and then greet Sam. So in this function that we defined, name is a parameter, and this means that we can use this name variable anywhere inside the function. So you can pass in different values like Alice or Sam each time you call the function, and they will be used in place of the name variable. So the values that we pass inside a function when calling it are called arguments. And let's run this code to see what it outputs to. So hello Alice, so in place of name this sends Alice, and this sends Sam. So hello Alice and hello Sam. So that was it about parameters and arguments of a function. Now let's get to the topic of returning values. One of the coolest things about function is that they can return values. This means that they can give you a result after performing some operation. For example, let's create a function that adds two numbers and returns the result. So function add, in place of the parameters we'll use a and b, which are the two numbers to be added. Let's say it returns a value of a plus b, and let's end the function. So let's say we want to store a sum of 5 and 3 inside the sum variable. So we'll use the function add to add 5 and 3, and if we print sum, it should give us the sum. So you might have guessed what is happening right here. Oh, I'm sorry, it should be b. So you might have guessed what is happening here. 5 is going inside this function in place of a, and 3 is going inside this function in place of b. So it returns a value of 5 plus 3. So this should print out to 8. And let's see if our function has worked as intended. So 8. So clearly our function works as intended. It takes two parameters a and b, and it returns the sum of those two numbers using the return keyword. So fun fact, functions in Lua don't have to return anything. You can just use them for their side effects, like printing something onto the screen without returning a value at all. And on the other hand, sometimes a function needs to return more than one value. In Lua, you can easily return multiple values from a function. So you can check this out with a function called get min and max. So let's say this also takes two parameters a and b, and if a is greater than b, then it returns first of all b, our minimum value, and a, our maximum value. Else it returns our a as our minimum value and b as the maximum value. So once again it's b. And let's end our if statement first with the end statement, and then our function with another end statement. So this is for our if statement, and this is for our function. So I hope that's clear. Now let's say we have to store our minimum and maximum value in two variables called min max, and these values will be provided by our get min max function. So let's say 10 and 20, and we'll print min, and then concatenation operator, our minimum value, and then max, and then our maximum value. So turns out I've made a small mistake. It should be returned right here, and let's see how this function will output. So as expected, since our minimum value is 10 and maximum value is 20, it outputs to min 10 and max 20. So this function was about returning more than one values. Here two values are being returned, one for the minimum, one for the maximum. And now let's talk about assigning functions to variables. A small segment. Functions in Lua are first-class citizens, which means that you can assign them to variables, pass them as arguments to other functions, and even return them from other functions. So I'll give you a small example to demonstrate what I'm saying. Local say hi. Let's say this is our variable which will store our function. And this will take our name as a parameter, and then it will print out, since the function is called say hi, let's say hi, and then concatenate our name, and then an exclamation mark. So this is a simple example just to showcase that functions can be assigned to variables as well in Lua. So say hi, let's say Charlie. So it should print out to hi Charlie. So hi Charlie. Here we assign a function to a variable called say hi, and then we can call it just like any other function with the variable name. So that was it about assigning functions to variables. And now we'll have a look at a topic called recursive functions. A function that calls itself. So a recursive function is a function that calls itself to solve a problem. This is often used in situations where a problem can be broken down into smaller and smaller sub-problems. So let's take a look at an example of factorial using recursion. A factorial is a product of all positive integers that are less than or equal to a number. For example, 5 factorial, this is the symbol for factorial, should equal to 5 times 4 times 3 times 2 times 1. So this is how a factorial works. And here's how to calculate the factorial of a number recursively. So we'll remove this function altogether to create a function called factorial, which will take n, as in our number, as a parameter. So inside the function we'll write a logic. If n is equal to 0, then return 1, and else return the number n times the factorial, that is our factorial function, of a numbers that is 1 smaller than our given number. So this part is calling the function again, and then end our if statement, and then end our function. So let's say I have to print the factorial of 3, which is simply 6, because 3's factorial is 3 times 2 times 1, which is equal to 6. Now this should give out 6. So I'll explain to you what is happening in this code right here. So let me just copy this code and create a text bubble. So what is happening here is, if we pass in 3, don't mind my handwriting, if we pass in 3 inside this n, that is in place of the n parameter, so it will check if n, that is 3, is equal to 0. So since it is not equal to 0, it will go to our else condition, which will return n, that is 3, times the factorial function again, but this time the parameter is n minus 1, which is 2. This n will stay as it is, that is our 3 will stay as it is, but this factorial function will trigger once again. So it will go inside this function, and remember our parameter here is n minus 1, which is equal to 2. So since 2 is not equal to 0, it will go to our else condition once again. It will return n, that is 2, times again this factorial function. So each time a smaller value is being passed into our factorial function, and this factorial function is being called again and again. So it will result in 3 times 2 times our factorial function. So it will check n minus 1, that is 2 minus 1, so it will equal to 1. So since this is still not equal to 0, it will return 1. And then the function triggers once again, and this time 1 minus 1 will equal to 0, so it will finally return 1. So it will return 1. And all of this will be returned by our initial function that was called. So 3 times 2 times 1 times 1, that is equal to 6. So it will return the factorial exactly. So I hope you could understand this factorial function well. The gist is that unless and until we have a breaking condition, that is n equal to 0, this function will be called again and again, and this will basically result in our value or our required value to be returned. So hope that is clear from this example. And that was basically it for this video about functions in Lua. Now it's time to test your function skills. So here's a challenge for you guys. So your challenge is to create a simple calculator program with functions for addition, subtraction, multiplication, and division. And bonus, you can allow the user to choose an operation and input 2 numbers. You can simulate this using variables for now. So if you liked the video or found this video helpful, please drop a like and subscribe to our channel for more such videos. And in the next episode, we're going to be discussing about tables in Lua. So do make sure you tune in. And until then, bye bye. Hey everyone, and welcome back to another episode of our Lua series. Let me ask you something. What if I told you there's a single data structure in Lua that can act like an array, a dictionary, an object, and even a prototype for inheritance all at once? Sounds wild, right? Well, in this episode, we're unlocking the full power of tables in Lua, Lua's most flexible and game-changing feature. We brushed over them back in episode 2 when we covered variables and data types, but today it is a full-blown crash course. And trust me, by the end of this video, you'll see tables in Lua not just as collections, but as the heart of Lua's magic. So stick around, because once you really understand tables, everything else in Lua starts to click. Alright, let's dive in and unleash the power of tables in Lua. So, like always, first and foremost, let's talk about what are tables in Lua. If variables are like single pockets in your backpack, tables are the whole backpack. They can store numbers, strings, other tables, and even functions. So pretty much everything. A table in Lua is like a container where you can store multiple values. You can think of it as a list, as in like a shopping list, a dictionary, and also like a record where you can store player info in a game. And unlike arrays in other languages, Lua tables are flexible. They can act as both arrays, that is indexed lists, and key value pairs, that is dictionaries. So in order to understand them, let's start with a basic list of items stored in a table. We will now create a simple table which will be like an array or a list. So for that we have our compiler, where we'll type out a table variable called fruits equals a set of curly braces and then our items to store. So we'll store strings in this case. So this is apple, and then banana, and then cherry. Simple as that. So this is our table. And keep in mind that indexing starts in Lua from 1 and not 0. Yes, that is different from many other languages, so we can access these items using indexing. And if I wanted to access apple or print out apple, I would type out print fruits, a set of square brackets, and our indexing for our first item, which is 1. So this should give out apple. And this is clear from it. You can also add new elements at the end of the table using table.insert. So if I wanted to add a fruit named orange at the end of this fruits table, I would type table dot insert the name of the table, that is fruits, and then the item you want to add. In our case, it's orange. Now this line essentially adds orange at the end of our fruits table, and we can check that by typing out print and then the fourth index of this table. So this should output to apple and then orange. And in order to remove this last item, we use table.remove. So table.remove and the table you want to remove an item from. So fruits. This removes orange. And now if we try to access the fourth index of our table fruits, let's see what will happen. So it gives us a nil value, and that is nothing, because nothing is present in the fourth index since we removed orange, which was present in the fourth index. Now what I just presented was about removing items from the end of the table, but if you want to remove an item from a specific index, you would have to do this. Well, suppose we want to remove banana, and remember that in Lua the indexing starts from 1, so it is at the first and second index. I mean first then second index we have banana. So in order to remove banana, I would have to print out table.remove the table name, that is fruits, and then our index. So as I said earlier, this will remove banana and cherry will take the place of index number 2. So let's run this code by trying to access our second index of fruits. So we'll have to type out print, then fruits, square bracket, and then the second index. So you can see that it gives out cherry. That means banana, which was initially present at the second index, has been removed successfully. Now these were the cases where the table acts as a list. And as discussed before, tables don't just hold lists. They can also store named values like a dictionary. So let's see with an example about storing player info. Let me just remove all of this and then create a new table local called player equals, and write our keys, that is name, and then our values Alex, a comma to separate our keys and values, and then another key score. Let's say Alex has a score of 1200, and then let's say Alex is at level 5. So here name, score, and level are keys, and the general format to store keys and values is keys equals values, and then a comma before the next key value pair. Keep the comma in mind or else it might throw an error, and we don't want that. So we access the values using our dot notation or square brackets, which I'll demonstrate right now. So print, if we want to access our player's name, let's say player name, and then concatenation operator, the name of our table, player, dot, and then the key value we want to access. So since we want to access Alex, that is our name, I would have to write player dot name. And if we want to print out the score of the player, I would say player. In this case, I'll use our square brackets. So player, and then inside our square brackets, we have to use quotation marks to access the keys. So score. Now this will output to our score being printed, and this will output to our name being printed. So let's run and see. So player name Alex and score 1200. Now using dot notation or square brackets is totally your choice, and you can use either one to access our key value pairs. Now if you want to modify a value or add a new key pair value, we can achieve it by doing this. So player dot score will update our value by typing out player dot score plus 100. So this increases the score. Now if you want to add a new key value pair, let's say we want to add the number of lives this player has. So I would want to type out player dot our new key name, that is lives, equals 3. So this adds a new key pair value. Oh, sorry, key value pair. Now we can access our score. So let's print out player.score and also print out our newly added key, that is player.lives. So we can observe that the score has been updated by this line right here, and we have added a new key value pair, that is lives. Okay, now that we have learned the basics of modifying tables in Lua, now let's have a look at how we can loop through them. You can loop through tables in Lua in two different ways. Since we have list style tables and dictionary style tables, there are two ways that you can use to loop for each of them. For list style tables, you can use something called ipairs, and for dictionary style tables, you can use something called pairs. They are really similar to each other with some slight differences. And first, we'll have a look at looping through list style tables, and that will be by using ipairs. So let's get into coding. So I'll create a new table called colors, and I'll add some colors. Let's say red, then green, and then blue. So in order to loop through this table, we'll have to use this syntax: for index, comma, value in ipairs, then our table name, that is colors, do, and then our code to be executed for each item in our table. So print color and then index, and let's say it'll print out color 1 red, color 2 green, color 3 blue. So color, in order for it to print out 1, we'll have to concatenate its index and then our actual color's value. So semicolon and then value and then end. So hopefully it'll work as intended. So color 1 red, color 2 green, and color 3 blue. Now for key value tables, we use pairs, and it is slightly different. So let's take our player table, for example, from before. So let me just Control Z all of this. And yeah, let's take this player table as an example. Now, if you want to loop through this table, we'll have to use this syntax. For instead of index, we have keys in our table. So we'll write key and then value. For key value in pairs, clear, that is our table name, do, print key dot dot and our semicolon, colon, and then dot dot value, and then our end keyword. So this should give out name Alex, score 1200, and level 5. So this has worked as intended. So you might be wondering why we have to use ipairs specifically for list-based tables and pairs for dictionary-based tables. So let's see if I use ipairs, what will be the result. You can see that this doesn't output to anything. So in order to loop through dictionary-like tables, we have to use pairs. So hope that is clear. And one thing you might have noticed, you will see that pairs loops through all the key value pairs, but the order is not guaranteed. So in our table, originally name, score, level is the order, but here score is printed out first, then name, then level. So using pairs does not guarantee your order, but if we use ipairs, it preserves the order. So that is why it is good for lists. Okay, now that we have learned about looping through our tables, we'll dive into the concept of nested tables, which will be our last topic for today's video. You can store a table inside another table, just like folders inside folders, and that is the whole concept of nested tables. Now I'll just remove this code and create a new table called game equals, and then it will have a key called title equals, let's say, Super Lua World, and then stats equals another table in which a score will be our key, score equals 3000, then comma, make sure you don't miss your commas just like I did, so lives equals 3. Now in order to access our title, we can just type game dot title, and we have discussed this earlier. Now if you want to access our score key or its value, we will have to use two dot operators. So print game dot stats dot score. So that's how you can access our values that are nested inside two tables. This is useful for organizing complex data like a game character's inventory. And that was it about nested tables. Not only nested tables, Lua allows you to set something called metatables. Metatables are tables that can add behavior to other tables. And I know it might sound a bit confusing right now, but here's a fun example that will help clear all of your doubts. So what we'll do is we'll try to create a table and access a key that is not present inside the table. So we'll create a table called local car equals speed equals value, or let's say 60. So this has only one key. First let's try to access that key. Print car dot speed. So this will simply output to 60. Now what we'll do is we'll try to access a key called max speed, and what will happen is this will result in a nil value being printed out since we have no key inside our car table called max speed. So let's run this and see. So 60 and nil. Now metatables can be a solution to handle this. We'll create a table. First we'll remove this, or let's say comment it out, and we'll create a table called metatable, which will hold a key called double underscore index. It will equal to a function which has table and key as its arguments or parameters, and let's say if key is equal to max speed, the key that we're trying to access, then it will return a max speed of 200. So let's end this if statement and then end our function. And after defining our metatable, we have to write one more line, that is set metatable, first our initial table that we are trying to access the non-existent key, and then our actual metatable, so metatable. Now this line attaches the metatable to the car table, and from now on any operation on the car table that Lua can't resolve directly, like accessing a missing key, will be handled by the meta methods, that is in double underscore index inside the metatable. Specifically, if you try to access a key that doesn't exist in car, Lua will first look for the key inside the car table, and if not found, it will look for this double underscore index variable inside the metatable. And if this variable is a function, as it is here, Lua will call it with car inside the table parameter and the missing key inside the key parameter. So you can think of double underscore index as a fallback mechanism. Okay, now that we have created our metatable and connected it to our car table, Let's try to perform our previous operations, that is trying to access this non-existent key. So I'll just cut this from here and print it out here. I'll remove the comment marks and let's see what our operation or code will result to. So you can see that 60 is printed as it is, and this value, which was supposed to return nil, is returning 200 now, since we have this fallback mechanism that is our meta table. So that was it for today's video. And before we actually end the video, we do have a mini challenge for you guys. The challenge is to create an inventory system for a game that stores items, that is keys, item and quantity. And this can be achieved through what we discussed today. You can also add new items to the inventory and remove some when used. And a bonus task, you can print all of the items using a loop or a special function when you want to print all of the items. So this is the task to follow. And that's it for episode 6. You just mastered tables, which are essential for structuring and storing data in Lua. From lists to inventories to game leaderboards, tables are everywhere. So if you like the video, don't forget to hit like, subscribe our channel for more such videos, and hit that bell so you don't miss the next episode. And until then, bye bye.
Before your Lua game saves a single high score or your Lua app remembers a user's name, one thing has to happen. Your code needs to talk to a Lua file. And that's what this episode is all about. How Lua handles input and output. So, we'll write data, we'll read it back, and we'll even delete it when we are done. And when you're building a game, a tool, or just exploring Lua, file handling is the foundation. And by the end of this video, you'll know exactly how to save your progress, save important data, and load it back like a pro. So let's jump in. And also, great news, if you have completed this course, you can head over to coding.com for your Lua certificate. And don't forget to download the Lua app from the Play Store today. Let's dive into the world of file handling, shall we? First of all, what is file handling? Well, file handling allows you to save data to a file, read data from a file, and modify files and update the stored data. Think of it like a notebook where you can write and read information whenever you need it. So first, let's talk about opening and closing files. In Lua, we use the io.open function to work with files. So first of all, let me open this folder that I created on my desktop, and I'll open command prompt inside this, and then I'll type in code space dot and hit enter. Now what this will do is this will open the folder in VS Code, and hopefully you have installed all of these extensions, that is Lua and then Code Runner mainly. So first of all, let's create a file called file.lua. So inside this file.lua, we will create a variable local called file. And inside this, we will use the io.open function to open a file. So for example, if I use io.open, let's say my file.txt, this is the extension of the file, and if we open the file in read mode, this should open the designated or this mentioned file in read mode. Now if we execute this file while saving this, nothing will happen. This won't throw an error even though we don't have any file called myfile.txt in this folder. So we can see that this code is being run from this Lua directory inside my desktop. We can see it from here as well. It is run from Lua directory inside the desktop. So what io.open essentially does is it searches for myfile.txt in the current directory where the Lua script is being run. So we can see that the Lua script is file.lua is being run from this desktop and the Lua directory. Now even though there aren't any files called myfile.txt in this directory, this doesn't throw an error yet. Now it will only throw an error when we try to use the file that is mentioned. Since there is no file present in the directory, this value will contain a nil value, that is nil value, which means nothing. Now if we try to use this value of file, if we try to read contents from a file, it will throw an error. Okay, so that was some basic knowledge about opening a file through Lua. Now let's write some data into a file. In order to write data into a file, you need to open a file in Lua, but you need to open it in read or append mode. And read mode is symbolized by a W, and append mode is symbolized by an A. Now I'll tell you what these different modes mean in a bit. But first, let's write into the file by using the read mode. The write mode. So we have opened this in the write mode, and now we'll hit enter, and we can write some contents into the file by using this function. So file and a colon and then the write function, and inside our quotes the string that is going to be written. So let's write hello Lua first. So hello Lua. Let's save this and let's see what happens when we execute it. So it says it has executed. Now let's check our directory where we have run the script, which is the Lua folder. Now you might notice that myfile.txt, a text document, has been automatically created. So if myfile.txt does not exist, Lua automatically creates it. But this only happens if we open the file in write mode or append mode. So if we write another content, let's see what happens. First, let's see what this myfile.txt contains. So we can see that it contains hello Lua, which is the text that we wrote into the file using our Lua script. Now if we write another text into our Lua or our file myfile.txt, let's say myfile.write learning file handling is fun, and let's save this and run this once again. So once again we can see that this code has been executed. Now if we check the myfile.txt file, we'll observe that learning file handling is fun is also written onto this text file. Now if we close this text file and open it once again, we'll see that this already contains some text, right? Now if I run this script once again, but I write something else instead of all this. So let's say I still open the file in write mode, and I write file and then write this has been overwritten, an exclamation mark, and save and then execute the script. We'll be able to observe that whatever was there before we had run the script has been overwritten. So this has been overwritten onto the file. So in order to prevent this, we can open the file in append mode. So if we open the file in append mode and then use the write function to write some text, it will not override the already existing text. It will just add on to this text. So let me demonstrate this with a small example. Now if we open the same file in append mode, that is A, and then let's say I write a /n and then type out this has been appended instead of overwritten, and then save it and then run it once again, we'll be able to observe that so this has been appended onto the file instead of it being overwritten. So I also added a code in between which is closing the file. Now this closing the file is very necessary because it helps to free system resources and it ensures that data is properly saved. So if you open a file, don't forget to close it. And now that we know about writing onto and appending onto a file, let's move on to reading from a file. So let's read the data that we just saved onto this folder. So onto this file, I mean. So let's read this data from our Lua script. Now I'll close this file and open our script and then go on to open this file in read mode. once again. So we are reading from a file, so we'll open this file in read mode, and then we can read from this file. So let's say we have a condition. Now remember when I told you if a file is not present, this line will return a nil value in this file variable. So we can add a check for that. So if file, then we can say local content equals to file colon and then read and then star and all. So this basically means it will read the entire file. So this will read the entire file. Now if our file is present, then it will read the contents of the file and then print the content. But if not, that is else, it will print file not found. It is important to close the file as well, so I'll type out file and close. Now let's save the script and then run it to find out what happens. Now we can see that the contents of the file that we just created have been read and then printed out to our output. So this is how you read contents from a file. Now if you want to read contents from a file line by line or just one line of the content, you can just swap all for line. So if you type out line, this reads one line of the file. So reads one line of the file. Let's save this and run this. So it should just print out the first line. So this has been overwritten, which is the first line of our document or text file has been printed out to our output. So this is how you read the file line by line. Now if I just copy this line and then name it content1 and then just copy this line as well and then swap content for content1, it should give out both the lines. So let me save this, and this should give out both the lines. So now if we print out content1 before content, it should print this has been over or this has been appended first. Okay, again save it and then execute it. It should print out this has been appended. So this is how you read the content line by line as well. Now we have discussed reading from a file, writing to a file, appending to a file, and now we remain of discussion how to remove a file using Lua. So removing a file is fairly simple. You just type out one line of code, and that is os.remove and then the name of the file that you want to remove. Now this is the relative path of the file, so this will only search for this file, or let's see in our case my file.txt in our current working directory. So this will only search for myfile.txt inside this this directory. It will search for my file inside this directory and then remove for the file. You can also put in the absolute path of the file as same as in while opening a file. While opening a file, you can put down just the name of the file. It will search for the file inside the current directory. But if you want to remove a specific file from anywhere, you can write its absolute path as well. So what this will do if we run this code is this will delete the myfile.txt that we have inside our Lua folder. So let's run this and let's see if the file has been deleted. So we can see that this file has myfile.txt has been deleted from our Lua folder. So that is how you delete a file using Lua. That was it for today's episode. And now it's time for a challenge. Your mission is to create a notepad system where the user can write and read notes. It allows multiple notes, that is in append mode, and bonus, you can also add an option to delete old notes. And with that, we are done with our video for today. If you liked the video, make sure you drop a like, subscribe to the channel for more such videos, and we'll keep delivering all of this to you. So until next time, bye bye.
Hey everybody, ever wanted to build your own game but didn't know where to start?
Well, today is your lucky day. In this tutorial, we're building a fully playable tic-tac-toe game in Lua, right in your terminal. No game engine, no external libraries, just pure Lua magic. And by the end, you'll have a working game you can play with your friends or even improve on your own, which will look something like this. So I'll run this code right here. We'll be coding this game in our own Codein's compiler, which runs the game perfectly fine. So it's player X's turn, and I'll choose the position 1, which represents the first square on our board. So I'll choose 2 for position 2 for player O, and I'll just make player 1 win for now. So 5 and 3. So for player X to win, we have to choose a position of 9. So I'll choose position 9, and as you can see, player X wins. So it has simple winner detection, draw detection, input validation, and all of that. So let's dive in. Now what we will be creating today is a 3x3 board game which has a turn-based play between X and O, and win and draw detection as well. And why Lua? It's lightweight, easy to learn, and perfect for scripting quick tools and games like this. Plus, once you understand these fundamentals, you can easily move on to more complex projects or game engines like Love 2D, on which we will be creating tutorials and releasing videos for you further in the future. So do stay tuned in. Now, let's code. I'll close this tab for now, or let's keep this in the background just in case we need it. So let's start by creating our game board in Lua. We use a simple table which represents the 3x3 grid, just a flat array with 9 elements. So we'll create a variable called local board equals. We'll just create empty spaces, 9 empty spaces for our 3x3 grid. Okay, so this is our board, and now we'll set the current player variable. So let's say local current player equals X. So this is our current player. Now each element in this table represents a position on the board from 1 to 9. So if I pick 1, it should fill this space with our symbol. So either it is X or O, it should fill it in this place. So to show the board, we use the print board function, which prints the current state of the game. So we'll create a function called print board, and first we will print an empty line, so a new line. So \n, and we will add a new line first so that every time the board is printed, it isn't cluttered. Then we will run a loop from 1 to 9 with a step number of 3. So we'll create a for loop for I equals 1 to 9, and then we want to increase each iteration by 3. And why we are doing this will be apparent in a while. So first it will start iterating from 1, and then in the next iteration it will start from 4, since 1 plus 3 equals 4. Now for each iteration we want to print, first of all, some empty space for cleanliness, and then concatenate the first or the iterating element of our board. So this is our board. We want in the first iteration to print out the first position, so I, and then we want to print out a line which separates the position, so this, and then concatenate our second position. So after 1 it's 2, so I plus 1, so I plus 1, and then another line for separation, and then finally our third element of our row, so I plus 2, I plus 2. Now every time the loop iterates, it will go 1, since it starts from 1, and 1 plus 1 is 2, so 2, and 1 plus 2 is 3, so 3. it will print out these 3 first, then it will go to the other iteration which starts from 4. So board 4 refers to this element right here, 4, 5, 6, and then it increases by 3, then 7, 7, 8, 9. So I hope you get the gist of the loop. Now we want to separate each row as well. So let's say if I is less than 7, then print a separating line. So 3 dashes, then a plus symbol, again 3 dashes, then a plus symbol and 3 dashes. So this will separate our rows. We'll end this if statement, we'll end the for loop, and finally we'll print a new line \n, and then end our function as well. So end. Now this displays a clean grid in the terminal like this. Now if we call the print board function and run our code, it will result in our board being printed. Now this could definitely be better, and you can make your own improvements. In fact, I encourage you to code along with me and try out all of these functions on your own. So this is how our board will be displayed. Okay, and now for the most interesting part, the win and draw detection. So we will define all of the winning combinations in our check win function. So first, to check for win, and we'll create a function called check win, which will have a table called local wins, and this table will have each possible combination for a win. So if we have a row full of our symbols, it's a win. So 1, 2, 3, 4, 5, 6, and then 7, 8, 9. Now if a column is full of our symbols, it's a win. So 1, 4, 7, 2, 5, 8, and then 3, 6, 9. So 3, 6, 9. And if our diagonal is full of our symbols, it's a win. So 1, 5, 9. So it's 1, 5, 9, and then 3, 5, 7. So 3, 5, 7. So I hope you understand that all of these are positions. So 1, 2, 3 is 1, 2, 3. So one row is a win. This is a win. This is a win. This is 1, 4, 7. So it's here. All of the combinations are here basically. So we loop through each set and check if all 3 spots match the current player. Now we'll create a for loop which has for underscore comma. Now this is for when you don't care what value it returns first. So in our case, if we want underscore and win in our ipairs, which is used to loop through list-based tables, so wins is our table which we want to loop through do. So why the underscore? If we loop through our wins table using for, it returns the index of the table, index of the element and the element itself. So index of the element will be returned in this underscore value, which we won't really use. So that is why we won't dedicate a separate variable when we just use an underscore. So this combination will be returned in this win variable. So since we do not care about the index, we do not separate a variable for it, and hence only use an underscore. So I hope you understand about that. So we'll create 3 variables called local a, b, and c, in which we will store our winning positions. So 1 will be stored in a, 2 will be stored in b, and 3 will be stored in c, and likewise for every element in this wins table. So win, which is our individual element, so for our iteration this is win for now for the first iteration. So wins first element. So remember that indexing is 1, starts from 1 in Lua. So win 2 and then win 3. So if our board's A position, that is our 1 position, equals to our current player, and our board's B position is equal to our current player once again, and if our board's C position is equal to our current player, we can safely say that the player has won. So then true. We'll end this for loop, and then I will end this if condition, and then we'll end the for loop, and then we can end the function as well. So end. So now I hope you understand this logic. So since we have every possible winning condition or combination inside our wins table, which will be contained inside each win, if A, B and C, that is our winning positions, are filled in the board with our players' remarks, that consecutive player will be winning or will have won. So if 1, 2, 3, if 1, 2, 3 are all filled with our current player, that is X symbol, if it's X, 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 then the current player, that is our X, will win. And as for our draw function, the draw function just checks if there are any empty spots left. So let's say to check for draw, and we'll create a function which will be named isDraw. So isDraw, and inside this we'll just run a for loop from 1 to 9. So do if board current position equals empty, then it automatically returns false. So since some of the positions, or at least one position, is empty on the board, it is not a draw, so it returns false. And we'll end this if statement and the if loop in the for loop, and if none of this, this should be returned, it returns false. And if none of the spaces are empty, that is, this condition is not true, our for loop ends and it returns true. So if none of the spaces are empty, it has definitely resulted in a draw. So we'll end the function. Now that was our checking function. And now for our game loop, we have to switch players. So after player X's turn, it should be player O's turn, and for that we have to create another function. So we'll call this function switch player. So switch player, and then if current player equals X, then we'll just switch it. So current player will equal to O, else, that is, if the current player is O, we will switch the current player to X. So simple as that. This is our switch player function. So end and then end. And now we will be writing our main game loop, and it runs until someone wins or the game ends in a draw. So let's write our comment, main game loop. So let's call this function play game. Now since we want to keep running this loop until someone wins or the game ends in a draw, we will have to use a while loop so that it keeps running as long as the condition is true. So while true, do, first of all we'll print the empty board so that our player knows that all of the spaces are empty. So print board, and now we will write onto the console that the player has to choose a position. So we'll use io.write function for that. So io.write, let's say player, and then we will indicate our current player, and let's say choose a position, and the position has to be between 1 and 9. So 1 and 9, and then we'll write this. So let's say we want to store the player's input. Now we will store the player's input in a variable called local position equals to first we'll use io.read function to accept input from the user, but since io.read accepts input in a string format, we will have to convert this into a number. So we'll use the function toNumber. So toNumber, and then we'll convert our input into a number. So after this, we will have to check if our number entered or input entered by the player is valid. So is it a number, or is it even between 1 and 9, and if the 1 to 9 position, or if the position that player entered is empty. So for example, if the player enters a position of 1, we have to check if it is a number. 1 is a number. If it falls between 1 to 9, it falls between 1 to 9, and if our first position is empty. So we'll have to create checks for all of that. So we'll use if position. This will return a true if the position, or if the input that the user entered is a number, and if position is more than or equal to 1, and position should be less than or equal to less than or equal to 9, and the position on the board should be empty, so equals to empty. Then only we can place the mark of the player on the board. So player board position equals to current player. So this is placing the current player's mark on the board. Now we have to check if the player has won. So after each mark in our while loop, after each iteration, we have to check if the current player has won after they place a sign, so or if they make a move. So if check win, that is if our player has won, then print the board first, because we have to show how the player won, and then print player, and then concatenate our current player, let's say wins, and then we'll break our while loop. So this will end the game. If not check win, then we have to check else if check draw or is draw, and if it is draw, then we have to print the board to show the result, and then we have to print it is a draw. So we have to break, and then if none of the players have won or have drawn, we have to switch the player. So switch player, and then we'll end our if condition. And then else, that is if our conditions are not true, if the player enters an input that is invalid according to our conditions, we have to print out invalid move. So try again, and then we have to end our if condition, and this we have to end our while loop, and then finally we have to end our function. So this is the complete code for our Tic Tac Toe game. So after that, we have to start the game by calling the play game. So let's say start the game, and we'll call our play game function. Let's run our code and see if this runs as expected. Okay, so it says unexpected symbol near true and Lua 31. We have to debug our code right here. So this should be return true.
So okay, 62. Oh, if we are setting the position or if we're assigning a position, we cannot use double equals to, we have to use equals to for assigning a value. So those were our errors, and you might encounter errors while you are following this tutorial as well. Make sure you look at the position where the error occurs and what the compiler says is the error, and you can fix all of the errors while programming. So it is all trial and error, so no worries even if you get errors at all. Now let's test our game that we just made. So first let's fill our player's position with 1. So as we can see, okay, I think there's an error once again. So is draw, we should return false if the player is empty and true if there is none. So for I to 9, oh, we have to put here I and not 1. I'm sorry, I'm really sorry. Now we have to run this code once again. So let's say we fill our position with 1, and then we fill player O's position with 2, and then player let's try to give an invalid input. So A, so it says invalid move and try again. So let's say we try to give an input of 19, so it again says invalid move, try again. And once we reach let's say if we try to put in 1 again, what happens? Let's see. So it'll again say invalid move, try again. And now let's aim for a win, shall we? So player X's position, it's 4. So player O's position, let's say it's 5, and player X's position, let's say it's 7. So it should return in 1, 5, 7. So it should result in player X winning. So it says player X wins. So our program is running fine. And now for our final check, let's see if it successfully prints out a draw message. So first of all, let's say player X chooses 1 and player O chooses 5, and player X chooses let's say 4, and then this is player X trying to win, so player O chooses 7 to block off player X. Now it's player O who's gonna win, so player X again tries to block off player O by choosing 3. Now player O chooses 2, and player X chooses 8. Player O chooses what is this, 6, and then player X chooses the only remaining option, that is 9. So it's a draw. So our draw function is working fine as well. So we have successfully made a tic-tac-toe game where the player switches turns and prints out draw misses or win misses accordingly by detection, and it also checks for invalid inputs. So all of our intended program is working well. And that's it. You've just built your very own tic-tac-toe game in Lua. So if you found this video helpful or fun, please smash that like button and subscribe for more Lua tutorials. We'll be releasing more such tutorials on simple games, and furthermore we'll be using Love 2D to build simple games in Lua in the further future. So if you want to stay notified, click on that bell icon as well. Drop a comment telling me what game should we build next, maybe Snake or Hangman. So do drop your suggestions in the comments. And thanks for coding with me, and as always, happy coding, and we'll see you guys in the next one. Thank you. Hello everybody, and welcome to episode 9 of our Lua series. And in today's episode, we're building a Hangman game in Lua, the classic game where you guess the letters before the stick figure meets its doom. So no libraries, no engines, just pure terminal Lua. Perfect for beginners or anyone looking to sharpen their logic skills. And by the end of this video, you'll have a complete word guessing game to challenge your friends with, and it'll look something like this. So I'll run this code, and this is our Hangman's hanger, and let's try to guess a letter. So T. So it says wrong guess, and it is adding figures to the hangman. So let's try to guess the word. If it's A, okay, so it has 3 letters in the word. So let's try O. So this is how the Hangman game works. Now I'll try B. Oh, so it's banana, I'm pretty sure. The word was banana, and we guessed it successfully. So this is how the game works, and if we do 6 number of wrong guesses, our stick figure completes and the game is over. So let's see how to code this in Lua. So let's quickly break down what we will build today. First of all, what is Hangman? Hangman is a game where hidden word is guessed one letter at a time. So its key mechanics include a hidden word that starts out as underscores, and 6 wrong guesses before the hangman is complete. Each wrong guess draws a new body part of the hangman, and the game ends when you either guess the word or the figure is complete. So now let's start building this step by step. First of all, we'll open this and we'll start with a list of words and use math.random to pick one. So for storing our list of words, we will use a table. So we'll use a list-based table. It'll have the words, let's say banana, then computer, then Lua, then hangman, and then terminal. So let's say this is our list of words, and we will use math.randomSeed os.time. Now what this does is it actually randomizes our random function that we'll use in the other line. So let's say local word equals our words table, and then math.random a random word from our words table. Now if we hadn't used math.randomSeed, the quote-unquote random order would always be the same while we play our game. So if it randomly picked Lua at first and then computer and then terminal and banana, it would pick the same random order again and again each time we play the game. So in order to avoid that, we use random seed, and this adjusts the seed that our random function picks according to os.time. So I hope you get why we use math.randomSeed. So we will create a table which will store our word letters. So a random word is selected and the random word's letters are stored in this table. Now for storing the letters of the word, we will use a for loop for I equals 1, comma, our word, that is the word that we picked, do word underscore letters ith index equals to word, then colon and sub I comma I, and then end. Now this gives us a table like banana. Suppose it gives us a table with the individual letters, so B, A, and then N, and then so on. So this is what word sub does in our 8th line. So after that, we will track our guesses. Now to start tracking guesses, we have to declare our initial game state. State. Now for that, we'll create a table called local guess letters equals to empty for now, and then local correct guesses for our correctly guessed letters equals this to empty. Now we will create a variable called max attempts to define our max number of attempts, which in our case is 6. And then we'll create a counter to track our wrong guesses as well. So wrong guesses equals 0 initially. And we'll create a function that displays the hidden word /word. So we'll create a function called display word. Display underscore word. And what this will do is it will create a variable called display, which will initially be empty, and it will run a for loop from 1, and it will iterate through the word letters. Do it will create a letter to store each letter from our table of letters from the selected word. So word letters I. If correct guesses and letter, then display equals display will concatenate, and if this is true, that is our correct guesses contains the letter, then we will concatenate the letter. Else display equals display dot and underscore. So end and then end. Now print \n word, and then it'll concatenate our display. So it will either be underscores or the correct guesses. So end. Now how this function will work is later in the game when we ask for our user input, we will check if that letter is contained in our word letters table, that is if it is a correct letter in the word, and if it is a correct letter we will add that onto our correct guesses like this. Suppose A is our letter, since since banana has A. Now if that guess is correct, we will later in the game logic add correct guesses A equals 2. Now what this will do is it will add A as a key in our correct guesses table, and its value will be 2. So for each 2 value, it will print out that value onto our displayed words. So suppose A is guessed correct, right? Now in our demonstration before, it printed out underscore A underscore A underscore A. Since banana has 3 A's, it will print out all of the letters, and this is how the for loop works. If the letter is correct, it will print out the correct letter, that is letter, and if the guess is incorrect, it will just print out a simple underscore. Now in the initial phase, it will just print out underscores since our correct guesses table won't have any guesses. So this is how our display word function works. Now I hope I was able to explain that properly. Now we will move on to our Hangman. So this part of our code will add the visual elements to our game. So we will say function to draw / display the Hangman. Now let's say function display Hangman, and then inside this we will create a table called Hangman. Local Hangman equals, we'll just type out a bunch of underscores for the stick of the Hangman, and then we'll create a straight line, bunch of spaces, and then another straight line. And after this, we will make a condition. Now in our Hangman table, we want to show different parts of the stick figure based on how many wrong guesses the player has made. And to do this, we use a shortcut in Lua called a ternary like conditional operation. That is the condition. So it works like this. First you write a condition like wrong guesses is more than or equal to 1, and then you use the AND keyword to tell Lua what to return if the condition is true. So in our case, we'll use AND a stick part and then the stickman's head. So oh, and then you use the OR keyword to tell Lua what to return if the condition is false. So in our case, we'll use just the part of the stick. So for example, in the third line of the table, we will use wrong guesses. If wrong guesses is more than or equal to 1, it should return the stick figure's head, else it should just return a stick. This lets us build the hangman drawing step by step, only showing the parts as per the player mistakes. So each line uses a similar condition to draw a body, arm and legs. So the next line will have, first we'll have to put a comma on this line, and the next line will have wrong guesses is equal to 2, and if the wrong guesses are equal to 2, we'll have to build the stickman's neck. So this first part is the part of the pole, this part of the pole is this part, and then the neck of the stickman, which is this. And then if the wrong guesses is equal to 3, then we will build one of its arms. So let's draw part of the pole first, and then we'll symbolize its arm, left arm, with a slash, and then its body, and then or nothing. So wrong guesses is more than or equal to 4, we will build part of the stick first, and then both the arms, so left arm, the body, and to write a backslash we have to write 2 backslashes since it's an escape character. The first backslash symbolizes the escape character, and the second backslash is the actual backslash. So or we will just draw part of the stick. And then wrong guesses is equal to 5, we will build the left leg, so and part of the pole, and then the left leg, so a slash. A slash, and then or, I'll just leave it at that. Wrong guesses more than or equal to 6, and then we'll build the part of the stick and its legs, so slash, and then 2 backslashes for one of the backslash to be printed out. So or it'll just be the part of the pole, simple. Now we just need the foot and the rest of the pole. So a line and then the foot of the pole, which we will symbolize by an underscore, and then a line and an underscore once again. So this will be our hangman table, and to display this hangman or the contents of this table, we will use a for loop. So for underscore, this is for the value we do not care about, the first value, which will typically be the index, and the second value, which will be each individual line of the table. So line in ipairs hangman table, do enter then print line, then we'll end the for loop, and then we'll end the function whole. So each incorrect guess reveals a part of the stick figure, and now we will create a function to check for the win. So let's say check for win, Then we'll create a function called isWinner, and it'll have a for loop with the same logic. Underscore, we don't care about the index, we care about the letter. In ipairs word letters, which is the table of the letters of our random word. So for letter in ipairs, that is our table. If not correct guesses letter, then we'll just return false, and then end our if condition, end our for loop. And if every letter in our ipairs, that is if our word letters table is present in our correct guesses, it should return true, since our word has already been guessed, and this will end. Now this works by checking if all the letters of our word letters table are present in our correct guesses table, and if it is not so, false is returned. But if all the letters of the word are present, true is returned, and the player is declared the winner. So this is how our check for win function will work. And now it's time for the core game logic, and here is the heart of the game, the main loop. So we'll symbolize this by writing main game loop. So this will contain a while true, since we want to run this loop over and over again until the player runs out of guesses or the player guesses the word. So while true, we will display the hangman at first. So display hangman, and then we will display the word, which will just be a bunch of underscores for now. So after that, we will take input from the user by using the io.write to prompt the user to guess a letter, and then we will take input from the user. So first we'll use io.write, and then we will say \n guess a letter. So guess a letter. After that, we will use first of all, we'll create a variable to store the player's guess. So we will use io.read and turn it into lowercase using the lower function. So if the length of our guess, the hashtag is used to derive the length of our guess, that is string, is not equal to, now the not symbol is symbolized by this symbol in Lua, is not equal to 1 or not. We'll use the match function to check if the guess is a letter or not. So we'll use the percentage sign along with a. This checks if the guess entered is a letter or not, so numbers aren't able to enter. So then print invalid input, enter a single letter. So we'll symbolize that we should enter a letter in our guess, else if guessed letters guess, then that is if the guess is already present in the guessed letters, then we should print you already guessed that letter, else the guessed letters guessed will be set to true. That is, we will add the letter that the user guesses into our guessed letters table as a key, and its value will be true. So this is adding our guessed letters into the guessed letters table. This line does that. Now after that, we'll create, no, this should be else actually, this should be else, and after that we will create a local variable called found. So local found So local found will set this value to false, and for each letter in the table word letters, we will check if the letter is equal to the guess. So if the letter is equal to the guess, then we will put that guess in our correct guesses table. So if the guess is correct, we have to put that guess in our correct guesses table. And the way we do that is like this line. We will write correct guesses, guess, we'll add the guess as a key, and we will set its value to true. And we'll set the found variable to true since we found the guess. And we'll write end, and then end once again. Well, if the found value is still false, that is if not found, then we will increase the count of our wrong guesses since that guess was indeed a wrong guess. So wrong guess. Wrong guesses plus 1. So now we have to make the user aware that the guess that they made was wrong. So wrong guess attempts left and we'll print out the max attempts value. So wrong guess, and we'll concatenate max attempts minus the amount of wrong guesses. So wrong guesses. So if the player makes one wrong guess, he or she has 5 numbers of attempts left. Since 6 minus 1 wrong guess, our max attempts are 6. So 6 minus 1 is equal to 5. So it will print out the max number of attempts the player has left. So end. And we'll check if the player has guessed the word successfully. Then is winner. Then we will display the word, and then we will print. First of all, we'll go to the new line, and then we will print congratulations. Oh, this should be in quotes, I'm sorry. \n, and then congratulations. You guessed the word. And then we'll concatenate the word that was guessed. And we'll break our loop. Now, if the player does not guess the word correctly, that is, if the wrong guessing is still going on, we will add a condition. That is, else if the player has not won yet, else if the wrong guesses is more than or equal to the max attempts, then we will display the hangman. So we will print in a new line, game over. The word was, and then we will write or concatenate the word in this as well. We'll use break, and then we'll use a bunch of ends. This end is for this if statement, another end for our top if statement, that is this end state if statement, and then another end for our while loop, so end. Now this completes our Hangman game's full code. So let's play a quick round to see it in action, and let's run to see if there are any errors in the code, since there might be any errors while coding a small project like this, and if there are any errors, we'll find it on the spot and fix it. And just I hope you guys coded along with me and got the same result. So let's run this and see if there are any errors. So yeah, okay, so turns out I've not placed an OR statement in our ternary statement on line 39, so that was what was causing the problem. And in the meanwhile, I found another error in our line 90. So this print statement has never been closed off in this line, so that was an error. And after fixing these errors, this game should run properly. Now let's run this game. So our poll is a bit tilted, but we can of course fix that through our string. But let's try to guess the letter, shall we? Or the word. So let's see if our letter A is in the word. Okay, so while testing the game, I found a bunch of errors, just spelling mistakes. I already fixed these errors, but turns out instead of ipairs, I had typed out ipairs. So ipairs in this line, and in line 56 too, I should have used ipairs. Now this should make the game work properly. Okay, so let's play this game. After guessing A, it says wrong guess and it draws the stickman's head. Now if I type out C, okay, so the word is computer, since I know this is computer since we have put computer in our local words, but you can of course change this these words as much as you like. So let's just see if the program is working as intended. So we'll type out A and then enter. You have already guessed that letter. It says we had typed out A at first, so it is checking if the word is already guessed or not, or if the letter is already guessed or not. So let's say it has Q. It is drawing the hangman, so let's say W. Again wrong guess. Oh, it is drawing the neck and the arm, left arm. So let's try B. Let's try Z. Okay, so execution time took longer to finish, so we should execute this quickly. A. Oh, so it is banana, so B. So we already guessed B now, and the word is banana. So the winning mechanism is working as intended. Let's see if the wrong mechanism is working. So if the hangman completes. So this is obviously Lua, so we'll just type out the letters of computer. So C, O, M, P, U. Oh, Lua has U. So let's say T. Oh, it is drawing the legs as well. E. Last attempt. Oh no, the game was over. The word was Lua. So our game over function is working as well. So this code is working completely as intended, although the alignment of the hangman is kind of messed up. You can always fix that through your text, and that was the game. And there you have it. You have just coded hangman in Lua, all in our own Codance compiler. And if you enjoyed this, drop a like, hit subscribe, and tell me in the comments what game should we build next. We are even planning to release videos regarding Love 2D, which is a game engine which uses Lua for its scripting, and we can build pretty interactive games with graphics inside Love 2D. But until then, happy coding and bye bye.